All right, so we are in geometry. We skipped the warm-up, so let's see how this procedure works. Today is March 8th, 3/8. All right, make sure your name and date are on the paper. All right, we're talking about inscribed angles. Again, this is one of the easiest lessons for the entire unit. All right, if we're borrowing pencils, make sure to give them back. What do I mean by inscribed? Inscribed means that the angle is attached, and I have my music going, is attached to the circumference. As a picture example, if I come over here and make a line, let's make one inscribed angle. You need to make an inscribed angle that doesn't look like mine. So don't put a point over here. Somehow make your inscribed angle slightly different than Mr. Sandell's. There's Mr. Sandell's inscribed angle. Try to make a different inscribed angle. And you can make multiple inscribed angles. But notice that there are 3 points. All of those 3 points are on the circumference of the circle. This angle, instead of being a central angle, is now, so the central angle would have been right here. No longer a central angle, it's an inscribed angle. That's what we're talking about today. Make an inscribed angle. All right, so let's talk about the inscribed angle theorem. So if I have a central angle and an inscribed angle both attached to points A, B, then this inscribed angle is half of this central angle. So,
can you scroll up just a tad bit?
Just a tad bit. All right, so what we're going to write down is that the inscribed angle on this star, the inscribed
Angle is attached to what?
attached to the circumference. The angle is attached to the circumference.
Inscribed.
Jaden's still writing. Other people are still writing. All right, and scrolling down. All right, so inscribed. Is that better? Inscribed angle is 1/2 of central angle. And I have 3 different pictures up here to show you what happens. In fact, I can move this point S. If I drag this point S along the circle, as long as this point S doesn't get in between this minor arc AC, it's always going to be the same angle. It does not change the angle, no matter where I drag it along this circumference of the circle. Kind of cool? All right, so that has some implications. That means if I have 2 angles, if I have this angle X and then this central angle must be what? And I forgot to pass out cards. Who wants to pass out cards first real quick? The inscribed angle must be what? If the inscribed angle is X, what must the central angle be? Quiet raised hand. The central angle must be, Colby? 2x, exactly. Everyone write it down. This central angle must be twice of the inscribed angle. And therefore, what is this other inscribed angle? This inscribed angle over here must be what? Quiet raised hand. The central angle is 2x, but this inscribed angle is also attached to this point A and B. Go for India. It is indeed x degrees. Yes. So kind of cool. If I have these 2 angles and they're both attached, these 2 inscribed angles are attached to point A, B, those 2 inscribed angles are the same no matter how I move them around. So this is what we want to write. If 2 inscribed angles are attached to the same endpoints, I cannot spell, endpoints. Then those angles are congruent. All of this is a fancy way of saying these two angles, this angle S, this angle T, those are the same angle. I will leave that up there so that everyone can copy it down. I know not everyone is as fast as a writer, or maybe some people are faster writers than I am.
We're not writing on the back.
Yes, there's one example on the back.
Okay. But I'm using Sharpie.
Do you want to switch to a pencil?
No, because
I highly recommend switching.
But it won't match.
It's okay, because then you'll actually be able to see what's going
I can see it. I don't even know who Sharpie is.
on. I just need the pencil back when you're done with it.
Can't make any promises.
All right. I see most people have stopped writing. All right, let's see how this theorem works in action. All right, so on your paper, you can't really see because I don't have color printer. I mean, we're just using black printer. So this blue angle ABC, this bigger angle, can we please stop making the poppy noise? This ABC central angle measures 112 degrees. Please stop. And then this inscribed angle, the red angle, ADC, it's the dashed angle, must be what? Is there a quiet raised hand that wants to solve this one for us? India's already participated though. I'll call on you if I need a backup. The question is example 1. Example 1. If ABC is 112, what does ADC equal? So I'm looking at this blue angle. I know what that blue angle is. I need to find this red angle. How am I going to do that? Stop. Sorry.
Can't you divide 112 by 2?
Yes, divide 112 by 2 and you get
56.
112 divided by 2 is equal to 56. Thank you, Martine. You can turn in your card. It's that easy. All right, example 2 on the back side.
Wait. I knew you saw me.
If I start with a central angle and I'm trying to get to an inscribed angle, I divide by 2. And
Wait, can you go up?
No, I haven't played in it.
Yeah, he played it. Ah, damn. I played last night. You were on the wrong side.
Did you really? I think I might have just cut my crops.
all right, Aurelio.
Sorry, it's just like.
Really? It's tough. You're embarrassing everyone.
All right, example 2. We're on the back.
Boss.
We're on the back. Now we know that the measure of angle ADC is 43. This red dashed angle right here is 43 degrees. I need to find the blue solid line, this angle right here. What am I going to do? Is there a quiet raised hand that can do this for us? I have one hand. There's only one person that can solve this. India's hand is up. 2 hands are up. There's only 2 people that know how to solve this. That's scary. I thought that this was, there's 3 hands. Go for Anna. Yep, so if I have 43 degrees, I'm going to multiply by 2, and I'm going to get 86 degrees. There's our final answer, and I can do that 86 degrees. I can make that blue because that's our blue angle, and there's our final answer, box it. You literally multiply by 2 or divide by 2, depending on what you're being asked for. If you're trying to go from something big to something small, divide by 2. If you're trying to get from something small to something big, multiply by 2. It's always a factor of 2 from inscribed to central angles. That's all there is. Multiply or divide by 2. You have one of 2 options. It's one of our easiest theorems of the entire year. And that's it. Go ahead and write your summaries.